Hello friends, welcome back to Civil Engineering Mastery. In this video, we are going to analyze a G+3 building in Staadpro software. In this analysis, we are going to consider dead load, live load as well as earthquake load, which is based on IS 1893-2006. So without further delay, let's move on. Before getting into the Staad software, let me explain you the architectural drawing. So this residential site is of 45 by 40. So this is the site dimension which is having ground floor and typical floor consisting of first floor and second floor, and this is the terrace floor. This is the architectural drawing. Here I have the framing plan: ground floor roof, first floor roof, second floor roof and third floor framing. So let's model the same in the Staadpro software. Open the Staad software, go to geometry. Here click Run Structure Wizard. In model type, you just go for frame models and click on bay frame. So we'll get this window. Here we need to enter all the values. Let me show you in the AutoCAD drawing. Length, height, width, number of bays along length, number of bays along height, number of bays along width. So this let me show you in AutoCAD drawing. We have 4 bays, 1, 2, 3, 4 in this direction, that is the length direction, and 1, 2, 3, 4 in the width direction. 4 bays, here also 4 bays. Let's see in the height wise. This is the frame elevation from plinth top. It is 6 feet 6 inches from the bottom of the footing, and then all the floors are 10 feet height. So we have totally 1, 2, 3, 4 and 5 bays. Height wise we have 5 bays. Let's add up the value. Length is 11.48, height is 14.172, width is 9.71. Let's give the breakups here. It is 3.15, 2.74, 2.44 and again it is 3.15. First let's add the plinth level, which is 1.98 and then 3.048, which is 10 feet height. Copy and paste because all the floors are of same height. Give OK. Next here it is 2.18, 0.45, 4.34, 2.74. Give apply, then close this one. It will ask you, would you like to transfer or merge this prototype into Staad? Give yes and then give OK. So here we want all our x, y, z values to be 0. It is origin, right? So let it be 0. Give OK. Now our frame is ready. Let's do few modification. Since we don't have these columns in the upper floor, let's delete all these things. So our frame look like this. This is plinth, ground, first, second and third. Let's do the modification. First select the plinth level. We need to modify as per the architectural drawing and our plinth beam layout. So we have the plinth beam plan here. So this is how we need to make this. So this we need to delete. We don't have, and this also we don't have. This we don't have. Let's delete that one. These 2 beams we don't have. Let's go to geometry, merge selected members. Now it is modified as per the plinth beam plan. Next let's go to ground floor roof and then modify it. Here is the ground floor roof framing plan. First we need to delete this. We have to merge. Go to geometry, merge selected members. Now it is modified as per the ground floor roof framing plan. Only thing we need to add this cantilever beam. If we measure from the center, it is 3 feet 4 inches. So here let's select this node and then Ctrl C, Ctrl V. Let's give 1 meter. It is in the x direction. Give -1. So the node is added here. We can connect now. Here also we need to merge this one. Now the cantilever beam is also added. Next let's do it for first floor roof. Here we have the framing plan. So according to this we need to modify here. Let's select everything. And here in the middle we don't have this beam. Let's delete. Even we don't have these columns. To merge this one, to geometry, merge. And we have to add one beam in the middle here. So let's see the dimension. From this column it is 5 feet 1 inch. If we take the center distance, it is 5 feet 1 inch plus 4 inch. Around 5 feet 5 inch will come. So this beam we need to add here. Let's give Control C, Control V. The Z direction, let's consider 5 feet 6 inches. Give 1.7 meter. You have to give negative because it is going in this direction. Next, let's delete this one. So this is the slab, and again here one slab is there. So now it is done according to the framing plan. And here we need to do few modification because from this column this beam is little bit inside. So let's see how much it is. 1 feet 10 inches plus 4.5 inches will come if we take the center to center distance. So let's keep it as 1 feet 3 inches. Sorry, 2 feet 3 inches. This beam we need to move. Control C, Control V. Let's give in the x direction minus 2 feet 3 inches is 0.675. Okay, then delete this one. It is done now. So here this is the primary beam and this behave as a secondary beam. We have modified. Anyway, this second floor roof is similar to first floor roof. So here let's go to the full view and then select this one and delete. Sorry, not this one. This one you can delete so that it looks like this, and then you can select this one, give translational repeat. In the y direction give 3.048 meter. Give OK. See, now it is copied. You see, exactly looks like the first floor roof framing plan. Next, let's go to the third floor roof framing plan. So here we need to delete this one. This we don't want. There is no other change. So let's merge this one. So now we have modified all the floors. Next, we need to define the member properties and support condition. Go to command, member property, prismatic. Here select rectangle. I'm going to choose my column size as 0.45, 450 mm, and then column width as 225 mm, which is 9 inches. Give add. And the same beam size I'm going to give 0.45 and then 0.225. Give add. Next we have 3 circular columns. So the dia is 9 inch. So give 225.225 meter. Give add. We have to assign these member properties now. So what I'm going to do is, this is my column property, this is my beam property, this is the circular column property. So I'm going to select beams parallel to X and beam parallel to Z. Now all the direction and Z direction members are got selected. Now I'm going to assign to selected beams. It is assigned now. Let me assign the member properties for column. Go to select beams parallel to Y, give Alt V. So my all the Y direction members are got selected. So only these 3 columns are circular. So what I'm going to do is, I'm going to select all these columns which are rectangular and then assign. Now member property is assigned for rectangular column. Next select the circular column and then I'm going to assign. Give assign. Column properties are assigned now. Next we need to assign the beam properties. Go to select beams parallel to X and then select beam parallel to Z. All the X direction members and Z direction members are got selected. So we need to assign the property now. Now all the properties are assigned. Even we can check. Go to select by missing attributes, missing property. See, no entity with missing property is found. So all the member properties are assigned for our structure. Next, let's define the support specification. Go to fixed and then add. Select the support and then select all the nodes. Give assign. Properties are assigned and support conditions are assigned. Let's change the column orientation. So these 5 columns are in 180 degree. 1, 2, 3, 4. Only these 4 columns are in 90 degree. This one, this. These 4 columns we need to change it to 90 degree. Go to commands, geometry constant, beta angle. So here give 90. Give OK. So this is changed. Now the column orientation has been modified. Now we need to define the load cases. Let's define the seismic load cases. Go to seismic definition, add. Under seismic parameters, you need to select the code IS 1893 2002 2016 is not updated in this version of Staad. So let's select this one. The parameters are given here. We can enter the values directly, or else we can go to generate. This is little bit deep, we can easily understand. Here we need to enter all the values. As we know, our zone is 3, so we have to select the zone which is 3. The value will come here. In table 3 it is given seismic zone factor. So our zone factor is 3. So for that the value of Z is 0.16. Next we need to choose the response reduction factor, importance factor and soil type. In table 9, response reduction factor or for building system which is given. So here we need to check for RC building with ordinary moment resisting frame OMRF. So here there is a note is given in note 1. RC and steel structures in seismic zones 3, 4 and 5 shall be designed to be ductile. Hence this system is not allowed in these seismic zones. So ours is zone 3. Because of that this system is not applicable. So we need to go for RC buildings with special moment resisting frame. So the value of R is going to be 5. Next we have to select the importance factor which is given in table 8. First one is given for school building or some special building. Second one is residential or commercial building other than those listed in serial number 1. So which is occupancy more than 200%. So ours is come with all other buildings. So the importance factor is 1. Soil type is given in the class 6.4.2.1. So ours is soil type is 2, medium or stiff soil. So this is used for calculating the SA by G value. However, we are going to give the value. The Staad will automatically calculate the SA by G value. Damping ratio is 5%. So let's enter the values here. Response reduction factor is 5 and our importance factor is 1. Soil type is medium soil. We need to select medium soil. Structure type is RC frame building. Damping ratio is 5%. Let's give generate. So all the values have been entered here. Now give add. After generating here damping ratio we need to change. It is 0.05. Give change. So you can see here it is changed. We are done with the definition of seismic load. Now let's add load case details. Give add. You have to remember that while adding the seismic load, we need to always first add the seismic load case. Before adding the dead load and live load, we need to add the seismic load case. So here loading type seismic and then I'm giving EQ X. Give add and next load type is seismic and then load case 2 is EQ negative X. And again load case 3 which is EQ Z. Next is load case 4 EQ negative Z. EQ load in Y direction is not that much significant, so we don't need to add that. Only X and Z directions are important. So that's why I'm adding positive X, positive Z and negative Z. So it is done. 4 load cases have been added. Next we can go with the dead load. Load case 5 is dead load and then load case 6 is live load. So we are done with all load case details. Now we need to add the loads. First let's add the dead load. So under dead load what and all will come? Self weight, main wall load, partition wall load, floor finish, parapet wall load, staircase load, everything will come under dead load. So I'm going to just add all the load cases, then just go to add member load. So we have main wall load as 11.48 kilonewton per meter. So this is the wall thickness 9 inch. Unit weight of the material brick I took it as 20 kilonewton per meter cube and 3 is the total floor height. From that I have deducted the depth of the beam. So we got 11.48 as the main wall load, 5.71 as partition wall load. So let's add that one. 11.48 add and then 5.71. 5.71. Next, what is the UDL we have? Parapet wall load we have 4.5 kilonewton per meter and then staircase load. So we have the staircase like this. So this is my landing and this is my going. I'm going to have a roof level beam over here. So at roof level beam we have to apply 16.02 kilonewton per meter. So this we are going to calculate per meter, and here at this area we have to provide a mid landing beam at mid landing level. So in that area we need to apply 14.4 kilonewton per meter. So I'm going to add that as well. Parapet wall load is 4.5 minus 4.5 kilonewton per meter. Add, and then staircase load, one is 16.02, 14.4. So all the UDL has been added. Next let's see what is remaining. And we have one more thing, cantilever slab load. In the ground floor roof we have one cantilever slab, and that cantilever slab load we are converting as a UDL and then applying on the beam. So that is comes around 9.77 kilonewton per meter. So that also let's add 9.77. So we have been added all the UDLs. Next let's add the floor loads. So we have self weight 3.125. I took the slab thickness as 5 inches. Next we have floor finish, that is 1 kilonewton per meter squared, and partition load, that is 1 kilonewton per meter squared. So totally 3.125 plus 1 plus 1. So totally we have 5 kilonewton per meter square as a floor load. So that floor load we need to apply it on the slab. Live load is 2 kilonewton per meter squared for residential building. For adding the floor loads, here we need to create a group for each floor so that we can assign the loads easily. Let me show you how to do that. Select ground floor roof. So here what we have to do is create a group by using Ctrl G. Give the name as ground floor roof. Here you are not supposed to give any space between the text, and select type as floor. Give OK. So here the group has created as a ground floor roof, but it is not assigned. So it is showing floor unassigned. So what you have to do, you have to select the floor which you have to create, and then you have to give assign. I'm not going to select this area because this is a staircase. There will not be any roof coming over there. So this is the main advantage where the group come into picture. So you don't need to apply the load on this area. Only whatever the slab portion is there, in that portion you have to apply the load. You have selected the geometry, and then here give associate to selected geometry, associate. See, now floor is assigned. Just select this one and then give highlight. So the floor whatever you have selected is highlighted here. So this is how you have to create a group for applying the floor load, which will be very easier, and you will be having the control over the load whatever you are applying. Similarly, you create group for all the floors. Here I have created groups for all the floors. Let's assign the loads now. Go to dead load, add, go to floor load. Here there is a option called group. You have to select this one, and then ground floor roof, just you give the slab weight and partition load, floor finished load all together you can give as 5.125. Give add. Similarly, next first floor roof, add, second floor roof, add. For third floor roof we can reduce it further. We don't have any partitions coming on the third floor, so just 4.125, 1 kilonewton per meter square we can reduce, and then give add. So everything has been added. We have to go to live load, then floor load, select group. Live load is 2 for residential building, add. First floor roof, add. Second floor roof, add. Third floor roof, add. See, now if you select this one, only that particular load has been assigned for ground floor roof. Next, if you select this first floor roof, it is only assigned for first floor roof, second floor roof, and then third floor roof. Similarly, live load also you can check. See, the group gives you the liberty to apply the load on each floor, and the loads will be under your control. Next, let's apply the wall loads. First, let's go with the plinth beam. So on the plinth beam, we'll be having all the outer walls or main walls. So main wall load we need to apply. So let's select all the walls. Just deselect the inner walls and columns. So we need to apply the wall load in this area. So give assign to selected beams and then assign. So the wall load has been assigned now, main wall load. Next, let's look into the partition walls. So here and this one, we can apply partition wall load here. So it is done. Next, staircase load we can apply here because it is starting from here. So this one we can apply. And then at the mid landing level there will be 14.4 kilonewton per meter that we have to apply in the ground floor. So next, let's go to the ground floor roof. So here there is a mid landing beam. I have added a mid landing beam. So in this one we need to apply this load assigned to selected beam, and then in the roof level beam we have to apply this load. so that is assigned, and all the periphery, the outer main walls are coming. So here we have to apply the main wall load, so that comes around 11.48 kilonewton per meter, so that we need to apply. And here there is a partition wall load has been assigned. Next we have to apply the cantilever slab load, as I told you before, which is 9.77 kilonewton per meter. Here there is a cantilever slab, so this slab load we are converting as a UDL and then applying on this beam. So that's what we are going to do here. So select this beam and then apply this load, 9.77 kilonewton per meter. So that is also done. Now we are done with the ground floor roof. Next let's go to first floor roof. Here we have the mid landing beam at 1.5 meter level. I have added a mid landing beam, so this is the load which is coming on the mid landing beam. And roof level, it is 16.02. Completing this one, and then we have the main wall load, so give this one and then assign to selected beams. It is assigned. Main wall load has been assigned. Next, partition load, here it will come. So there is no cantilever is coming on the first floor roof. Next let's go to the second floor roof. So here the case is different. We need to apply this one, the staircase load, mid landing level and the roof level. In third floor we are having the structure only in this area, so parapet wall load we have to apply in this area on the second floor roof. We have applied the staircase load and only in this area will be having the main wall load. Here we are having the partition wall load, and parapet wall we are having over here. We need to apply the parapet wall load on this area, that is 4.5 kilonewton per meter. So now we have assigned all the loads. Only thing we need to add is self weight. So go to dead load. So because self weight of the slab we have already added, self weight of the beam and columns are not added here, so that we need to add. Go to dead load, self weight, add, and this one, select this one, give assign to view, assign. See, now all the loads has been assigned. Go to definitions, seismic definition. So here we have to add the loads. Seismic calculation means what we are going to do? We are going to calculate the weight of the building at the time of seismic load. What is the weight of the building? Dead load plus live load. Seismic weight of floors, this we need to add. So seismic weight of each floor is full dead load plus appropriate amount of imposed load. Full dead load we need to consider, and appropriate amount of imposed load as specified in 7.3. Calculation of seismic forces in building. Imposed load on roof need not be considered. So there will not be any live load on the roof while calculating the seismic weight. And there is a percentage of imposed load to be considered calculating the seismic weight. So here we need to consider the percentage. For live load up to and including 3, 25% of live load we need to consider. Above 3 means we need to consider 50%. As it is mentioned in the code, the total seismic weight of the building is dead load plus live load. So that we need to add. Dead load will remain same for all the floors. Live load percentage we need to consider according to the seismic code. Now we need to add the seismic weight. Seismic weight is the weight of dead load plus live load, which is given in the code. So dead load will remain same for all the floors and live load will change according to the class mentioned in the code. For up to 3 live load we need to add 25%, and above 3 we need to add 50% of the live load. So on the roof there will not be any live load which is mentioned in the code. So for that we have to go to the Staad editor mode and then here select all the member loads, copy that and then paste it in the read. Here you have to delete the negative sign and GY. So all the wall load and beam weight, everything will come on the structure, so that we have to add it as a dead load while calculating the seismic weight. So now it is done. So we can copy this and then go to Staad editor mode. See here, after the definition of the seismic load, we can paste it the member load. See, all the member loads have been added now. On save and then close. If you go to definitions, under this one whatever the member weight we have added, it is shown here. We are not supposed to use the negative sign while adding the seismic weight. Next, we can add the self weight. Self weight factor, it is 1. Give add, close, and then we can add the floor weight. First ground floor roof, it is 5.125. Here also we are not supposed to give the negative sign. Add, and then for second floor roof, first floor roof, and then second floor roof, terrace floor roof, we can make it as 4.25. Similarly, live load we can add, which is 0.5 kilonewton per meter square, because we are having the live load as 2 kilonewton per meter square. 25% of 2 is 0.5. So we have to enter 0.5 for ground floor roof, add, and first floor roof also the same, second floor roof also the same. The third floor roof is the roof of the building, so that there will not be any live load, which is mentioned in the code. See, everything has been added here. Now we need to assign the earthquake loads. Under load case detail, go to EQX, add. Here select seismic load, which is 1, factor is 1. Next select negative x, the factor is -1. Select the seismic load and the factor is -1. Add. Next go to EQZ, select seismic load, factor is 1, and the next one is EQ -Z. Go to seismic load and then here -1. All the seismic load has been assigned. Now we can run the analysis. Go to analyze, give run analysis. See, there is no error and warnings. Now you can check whether the loads has been assigned or not. See, this is assigned in the positive x direction. You can reduce that size, scale size. Next, in the negative x direction, positive z direction. Sorry, I made it a mistake. Here it should be in the z direction.
Direction we need to change.
And again this also, the direction change, close. Now again run analysis. Now you can see it is in the negative z direction. This is positive z direction, negative x direction, and positive x direction. So friends, I hope this video was very helpful for you. Please do comment in the comment box. Your comments are always welcome. And don't forget to subscribe the channel for more videos. In the next part of this video, let's design the same structure and then get the results. Thank you for watching.